What's up, good people? This is Mr. Bergman here with section 5.2, solving polynomial equations algebraically. And so last section we did the exact same thing. We were trying to find that one or two or three values of x that solved the equation, and we did that by graphing. And today we're going to do it by algebraically, the techniques. And you remember, just flashback to chapter 3. You remember what we did. What this looked like was finding greatest common factors, splitting the middle, quadratic formula, all that stuff. We're going to bump it up a notch, and we're going to combine them. Sometimes we'll have multiple techniques, and at the same time kind of running together, and it's going to be a wild ride, but here we go together. The big idea is going to be when factoring a polynomial, it's often your responsibility to choose the technique or the combo of techniques that applies. So let's remind ourselves, technique number one, it's a review kind of. You can always do this first, check for the greatest common factor. So you can see here, if we had to solve this, we're like, previously in chapter 3, we've only seen exponents as high as 2, but now they're up to 3. So if we're going to solve this, we're like, wait a second, I see 3 terms here and they all have a greatest common factor of a. Factor out the a, boom. And then we got a squared minus 9a plus 14. Okay, I remember how to do this from chapter 3. I can split the middle. And what two numbers but multiply up to positive 14 and also add up to negative 9? That's minus 2 and minus 7 right here. And so then we can split this up into 3 different parts. From this portion, we see that a minus 7 is going to equal to 0, so that's the solution. A minus 2 is going to equal 0, so positive 2 is the solution. And then over here, if a is all by itself, it's basically like a minus 0 is equal to 0. If you put 0 in for a here, then you see it'll also solve the equation. So this equation has 3 different solutions, 0, 2, and 7. Let's do that again. Here, check. It's always a good idea to check for the greatest common factor first. And you can see here, wait a second, we've got t squared is going to be the greatest common factor because the t squared goes into all 3 of these terms. So factor out the t squared. And then you can see over here, we've got this portion of the equation looks like chapter 3. We can do quadratic formula if you wanted to, or I think it's just easier to split the middle. Minus 40, what two numbers multiply up to minus 40? That also add up to minus 3. That's going to be minus 8 and plus 5. So here from this factor we get from t minus 8 we get 8, and from t plus 5 we get negative 5, and then of course we've got a t squared over here which is 0. So that's that. Let's remember that we've got these formulas as well. This is to add to the list of previous techniques. We also have our perfect square trinomial formulas and difference of square formulas. And you remember, if it's in this format, a squared minus 2ab plus b squared, then we can change it into a minus b squared. So the greatest common factor is x. Factor out an x, and then once this is a quadratic, we went, oh, wait a second, this is a squared minus 2ab plus b squared. This is because it's immediately like most recognizable because the first and last terms are perfect squares. They're only perfect squares if the a were equal to x and if the b were equal to 4. If that's true, then this other side of the formula says that a minus b or x minus 4 is squared. So this x comes down, goes along for the ride. You just recopy it, and it's just like the equals 0, but we change this factor on the inside to just x minus 4 squared. And so 0 is the number that solves this factor right here, and 4 is the number that solves this part. Even if it's squared, it's still just, there's only one here. It's 4. So there's 2 solutions, 0 and 4. Here, sometimes it's just a lot easier to solve things when they're all set equal to 0, so that's the first thing we can do. We get x cubed minus 3x squared is equal to 0. Factor out an x squared, and so 0 solves this factor, and 3 solves this one over here. Alright, this just in, there's a new way to do technique too. It's called box factor. Alex calls it factor by grouping, but factor by grouping is a little complex to explain, kind of tricky and weird, but I think box factoring is way easier. So although it's easier, you click an explanation in Alex, and it's actually not going to, it's going to show you a factor by grouping explanation. And anytime you see that, you got to remember, wait a minute, Bergman taught me an easier way to think about this. You can learn factor by grouping if you want and use it, and maybe you'll even like it better than box factoring, but I just think it's so easy to do box factor. Not so easy, so much more simpler than factor by grouping. 4 terms. Anytime you have 4 terms, you can do factor by grouping or box factor. But I think if you've got 4 terms, you should just put them into a 2 by 2 box, just like we've been distributing, or just like we've been foiling, with box foiling, box factor. They're going to be reverses of each other. So for example, here, let's say we have these 4 terms. You might ask yourself, gosh, what was it that I needed to FOIL in the first place to get these 4 terms? Well, if you were box foiling, you would put the terms on the outside, and then you would multiply to get what's inside. But we're going to reverse that. The reverse of box foiling is box factoring, and it looks like this. So in box foiling, you started with terms on the outside. Then here, we're going to start with terms on the inside. Take those 4 terms and put them on the inside, like this. Well, it doesn't really matter a whole. There's a couple of right ways of doing this, but I just like to read basically from left to right: ax, bx, ay, by. The most important thing is that you've got the most complex term, like x cubed over here, should go in the top left, and the least complex term, like the lowest order term, goes diagonally from it. If you do that, then you can set them up, put them in here however you want. So then the next question you have to ask is, what is the GCF? What's the greatest common factor between these 2 terms? And it is, in this case, a. A is a factor of both ax and ay. You can put it right there. You can ask the same question here. In fact, you could ask the same question 4 times, one for each of these 4 terms. What's the greatest common factor here? Oh, it's b. So we put it there. Then, over here, you could ask the same question, what's the greatest common factor between these 2 terms? And you can see it's x. But if you wanted to, you could also just ask yourself, because you already have an a, what times a would give me ax? Oh, it's just x. What times a would give me ay? It would just be y, which also happens to be the greatest common factor. So, at the end of the day, what you needed to FOIL in the first place to arrive at these 4 terms is this. I'll get my head out of the way. A plus b, and x plus y. If you were to FOIL this out, you'd get back to the original of our problem. So we're reversing the box foiling with box factoring. Let's do the same thing again over here. Let's take these 4 terms and put them inside of a box. I said, let's take these 4 terms and put them inside of a box. There it is. X cubed minus 2x squared, 5x. And actually, like, there's lots of right ways to fill it out. I just go 1, 2, 3, 4. But you have to make sure, the critical thing is to make sure that this x cubed and negative 10 are diagonally from each other. You could swap these out, the locations, and still arrive at the same answer, or a correct answer. Anyway, first thing you do is you ask yourself what's the greatest common factor between these 2, and it is x. And then what's the greatest common factor between these 2? I'm going to say it's negative 2. You could ask yourself here, greatest common factor, or you could also, between these 2 terms, or you could just say x times what gives me x cubed? It's x squared. X times what gives me 5x? It's 5. 5 is also the greatest common factor between 5x and negative 10. So now, here we have the 4 things we need to write the solution. It's going to be x minus 2 times x squared plus 5. Yeehaw. Let's do this again. 4 terms inside of a box. Like that. And then greatest common factor. There are 4 different spots for greatest common factor, and it doesn't matter which one you do first. You could say, just for consistency, I'm going to do this one here, but you could just do any one of these you want. What's the greatest common factor? The easiest greatest common factor you can look at, you can do that first. I'm just going to do this one. It's x, because x is a factor of 4x and 3x cubed. Greatest common factor here is 2. Greatest common factor horizontally. What if you didn't know what it was? You could also ask, what times x gives me 3x cubed? It is 3x squared. What times x gives me 4x? It's 4, which also happens to be the greatest common factor down here. Then we can see down here, now we have what we need in order to write the factored version. It looks like this: 3x squared plus 4 times x plus 2. And I just wanted to drop right now for the audio check what's my favorite episode of The Office. It's the very last one, the season 8 finale, where Michael Scott comes back for just one line for his cameo. The whole episode is really wonderful to watch for me. Why don't you tell me what you love about The Office if you've seen The Office when you see each other in class? All right, one last one of these box factoring. So 4 terms go in the middle. Boom. I said boom. And then you could ask greatest common factor of any pair of these. This one, this one, this one, this one. You could start off with, but I'm going to start with down up here. The greatest common factor between these two terms is x. Greatest common factor between these two terms is going to be 3. X times what is 4x cubed? 4x squared. X times what gives you negative 9x? That's negative 9. But these are also happens to be the greatest common factors of the top row and the bottom row. Then now we have what we need in order to write the factored version. If you were to FOIL x plus 3 and 4x squared minus 9, you would get back to this to the original.